Okay, so you're gonna need to know relative velocity problems. I'm not gonna go over them because you have the video, so you can just watch the lectures again. But you should know the river problems with current. You should know these type Huck Finn problems where there's a top object relative to the middle object. So the velocity of the bug relative to the car plus the velocity of the car relative to the ground equals to the velocity of the top object relative to the bottom or fixed object. So you add these two vectors to get to your third vector. So the top relative to the middle plus the middle relative to the bottom or a fixed object equals to the top relative to the bottom. And you add these two vectors to find that third vector. There is this Huck Finn problem and this boat problem. So here the velocity of the passenger relative to the boat plus the boat relative to the water equals to the person relative to the water. Okay, so then we went on to kinematics. We found that we did this paramecium problem. So the average speed equals the distance traveled over time elapsed, and the average velocity equals to the displacement over time elapsed. Displacement is the distance from the beginning to the end point. So we found here that the distance from the beginning to the end point was 0. So average velocity is 0. But average speed is the total distance traveled, so you count that whole process. But for velocity, you're only looking at displacement, which is only the beginning and the end point. Make sure you know your prefixes, the important ones like millimeter, centimeter, micrometer, nanometer, megameter is 10 to the 6th, gigameter, giga is 10 to the 9th, and kilometer is 10 to the 3rd. So you definitely need to know kilo. Okay. We had 1D, 2D kinematics. A lot of times we found the x distance here. You find time through the y component and then substitute the time into the x component to find the x distance. But there's also other variations where maybe you'll find initial velocity or other things. But the most typical one is finding this x direction. Then we moved on to tension problems or finding force normal, finding some of the forces in the y direction equals to mass times acceleration in the y direction, some of the forces in the x direction equals to mass times acceleration in the x direction. So for this type of problem, this box will only move if this weight is greater than the weight of the box, because tension force is being balanced by the weight of the box. Once this box lifts up from the surface, then there is no normal force. Normal force is only if this box is sitting on the surface. For this problem, there is an x direction. Acceleration moves in the x direction for box A, and acceleration moves in the y direction for box B. And here, the tension force is being balanced by friction force. So that's why for this problem, a 2 kilogram box B can move a 5 kilogram box A. Okay, so we moved on to friction force. So this is the maximum static friction force So you keep adding force until you hit that maximum static friction force, and then the box or the object will start moving. And kinetic friction force is a constant, while static friction force has a maximum, but it's not always constant. Before this maximum point, static friction will equal to the applied force. And note that, well, for this problem, we found what is that maximum point. We found that maximum point is 66 newtons. So the maximum static friction force is 66 newtons. So you need to have a force of at least 66 newtons for the box to move. Okay, so here if it's 40 newtons applied force, then static friction force is also 40 newtons. Okay. So at 85 newtons, that's greater than the maximum static friction force. So you're going to move into kinetic friction force because the box will start moving after a force that's greater than 66 newtons. So for these friction problems, there's a good chance you need to find force normal. So you need to find some of the forces in the y direction equals to ma. Usually for this problem, yeah, the box isn't moving up or down. It's just in the x direction. So acceleration in the y direction equals to 0. Okay, so you go to some of the forces in the y direction to find force normal. Okay. And here again, acceleration is the same magnitude because it's the same motion, so same acceleration. But this box is moving in the x direction, this box is moving in the y direction. This box has both friction force and a normal force because it's sitting on a surface. This box only has a tension force. There is no surface, so no normal force, no friction force. And then finally, we did an incline problem. So all of the incline problems should look similar. You know, skier, crate, the object can change, but it's basically asking the same thing. And then you're going to use kinematic equations to find further questions, to answer further questions like the speed at the bottom of the incline. Just for these problems, make sure that acceleration and the distance is in the same axis. Okay, homework 15 due at the beginning of the final, May 7th at 9 a.m. So it's on incline, so page 104, number 53, 56, 57, 59. So 4 problems. All right, that's it. God bless. We'll be praying for you this week for finals. Finish strong. You can do it. You can do everything through Him who gives you strength. Good job persevering this semester through all these circumstances. Great job, guys. It's been a pleasure having you in my class. And I hope you learned a lot and enjoyed this class and that it gave you good skills for your future. Okay, God bless. Bye.